Hi there, this video is about the concept of disjoint events. Okay, so we have two events A and B, and they're called disjoint or mutually exclusive if they have no outcomes in common and can never happen simultaneously. So, one kind of easy example of this before we do these is, imagine rolling a six-sided die. So if we roll a six-sided die, what are our chances, right? We have one through six, that's our sample space. One, two, three, four, five, six. And we're talking about only rolling one die. So could I get a one, and a six in one roll? Could I get a one and a six in one roll? No. So those events would be mutually exclusive or disjoint. I couldn't get a one or a six in one roll. No. So that's an example. I mean, it's nonsensical in the same roll. No way, right? You're gonna fall on one of these. So if I get a one, I can't also get a six at the same time. If I get a two, I can't also get a four at the same time. So if they have no outcomes in common, it can never happen simultaneously. So that's what this idea is. This can be shown in an event diagram. So it looks like this. So here's event A and event B, and they have no overlap. So in other words, event A could be getting a 1, event B could be getting a 6. Um, and for this, with one die roll, you would have a circle for each one of these: event A, event B, event C, event D, event E, event F, and they would have no overlap. The circles would just be by themselves. Okay, let's look at this first example. A cooler contains 20 bottles made of 8 Cokes, 5 Pepsis, and 7 waters. So the probability of choosing a Coke or a Pepsi is. What I would do is add up 8, 5, and 7 to get my total number of possibilities for my denominator, right? In my probability, right? I have 20 total bottles. And then if I made a picture of this, well, okay, what are the three options I have? I have Coke, I have Pepsi, and I have water. And in one grab into this cooler, right? I grab with my hand into this cooler. Here are my drinks in there. There are my Pepsis, my Cokes, my waters, right? Maybe there's some ice in there. Right. I stick my hand in there and I'm only picking one in this selection. So it's pretty easy to see that I'm either going to get a Coke, I'm going to get a Pepsi, or I'm going to get a water. I can't get a Pepsi and the water at the same time, drawing one bottle out, right? That's what the mutually exclusive idea is. And in a Venn diagram, the picture shows no overlap. In this case, when you see this or choosing a Coke or a Pepsi, that's a signal for addition. So a Coke. So what's the chances of the Coke? So this is Coke. So I've got 8 out of 20 plus this was Pepsi. They didn't ask me about the water. So plus 5 out of 20. And then I'm going to add those up and I get 13 out of 20. So that's going to end up being my probability of choosing either a Coke or a Pepsi when these events are mutually exclusive or disjoint. I can just add those two probabilities, okay? So that's the concept of disjoint and exclusive. I guess real quick, we can do one more example. I've got a parking lot with 20 American cars, 40 Japanese cars, 35 German cars. The probability of choosing a foreign car. All right, well, so again, it's the idea I'm either an American car, I'm a Japanese car, or I'm a German car. So I'm not, those are mutually exclusive. I can't be both. Okay, at least in this scenario. In real life, the parts come from everywhere. Okay, so 20 American, 40 Japanese, 35 German cars. So they're my different cars. And then I want to know the chance of getting a foreign car. So that's basically going to be either Japanese or German. So it's one or the other. So you can see my Venn diagram, there's going to be no overlap on one or the other. I'm just going to add up. I have 95 total. 20 plus 40 plus 35 is 95. That's where this comes from. And then I can just add those up. My last example, I've got 25 men, 15 play golf, 7 play tennis. The probability of choosing a man who plays golf or tennis. Now, they're kind of giving us the answer here, but this is an example. You will get questions on this kind of stuff. They cannot be found as playing golf and playing tennis are not disjoint. So in other words, could I be one of these men and play golf and tennis? Yeah. So the situation is going to look different. So here I've got the 25 men. There could be some overlap. So if I've got 25 men total, if I add 15 and 7, that's 22. So I've got 3 men who aren't accountable, right? Because why is that? Because if I've got, they say there are 25 total, these two add up to 22. So I've got 15 in golf, I've got 7 in tennis, so I've got 22 accounted for in this, but I've got 3 that I'm not sure what they're doing. So it could be that those 3 men it could be that they are mutually exclusive, and then I've got 15 that play golf and 7 that play tennis and 3 that don't play either golf or tennis who would be out here. Or I could have, 3 that play golf and tennis, and then I would have 12 here and 4 here. But there's no way from the information here to know what the situation is. I mean, they just tell us that we've got 25 men, 15 play golf, and 7 play tennis. If they tell us they're mutually exclusive or disjoint, it would have to be this picture where we've got our 3 out who don't play either. That's the only thing we could do if those are going to be disjoint. But if they don't say that, we could have 3 that play golf and tennis, and then these wouldn't be disjoint. So we couldn't simply add the probabilities necessarily here. And we'll talk more about that in the next video. Okay, thank you.